So today we are going to talk about conic sections, and what conic sections is it is an intersection of a plane and a double naped cone. So as you can see in the picture over here, you have a cone that's represented in blue, and then you have a plane that is represented in red, and there are, depending on which way you slice this cone with the plane, you get different shapes. And the one thing to remember is that the plane does not pass through the vertex of the cone. So you can see in every one of them, whether it's a circle, ellipse, parabola, or hyperbola, you're not actually slicing it through the vertex. Now, these conic sections can also be represented algebraically as a second degree equation, and it kind of looks like this. We don't deal much with this, but it's as in we will see all the equations of each of the conic sections, but this is just how the general form of a conic section is, right? The third way to define conic sections, it's defined as a locus, which also means collection, of points satisfying a certain geometric property. And you will soon see what I mean by this, right? So let's start with the first one, which is a circle. Now, a circle is a curve that is formed at the intersection of a plane and the double cone, so that the plane is perpendicular to the axis. So if I were to draw the axis going down straight like this, the plane is, you can see, perpendicular to this. Sometimes you can also say that the plane is parallel to the base. So if this is the base of the cone, right, you can see how the plane is parallel to the base. So it's either parallel to the base or it's perpendicular to the axis. So when you slice it that way, you get a circle. You can see in red here, and the red dotted line, right? So that's like the circle. So that is how the circle is defined. Now let's go to actually the other definition, which deals with the locus. So a circle is defined as a collection of all points xy that are equidistant from a fixed point hk. What does that mean? So let's take a point, right? H comma k. Then I draw a line, and this is x comma y. Now I'm going to call this distance some r. Now if I draw a bunch of lines, again this is x1, y1, this will be x2, y2, all the length is r, okay? Every length that I draw here will be r. x3, y3, and I keep doing this, right? I keep doing this, and my condition is that from this fixed point hk, every line is equidistant. And I keep on doing this. And then I join all these points, and you can see that I get a circle. So it's a collection of all points xy that are equidistant from the fixed point hk. Now, if you go back to your distance formula and apply it, if I want to find out this distance r, you can see if you apply the distance formula, it would be nothing but x minus h the whole square plus y minus k the whole square. And this is the equation of a circle. Is the equation of a circle with radius r and the center point is h comma k. Now, if this center point is the origin, if h comma k is the origin, which is nothing but 0, 0, then the equation of your circle becomes x square plus y square is equal to r square. Obviously, right? For h and k, I'm substituting 0, 0. So I'm going to get x square plus y square is equal to r square. Okay. So this is circle. Circle is the easiest. We have seen a circle from like even elementary school onwards. You're just learning more and more things about the circle. Now, before we look at some problems or questions associated with circle, one theorem that you should know when you're doing this is there is a theorem in geometry that states that if you have a circle and then this is the center, okay, and you have a tangent line here, okay, this is your tangent line, this is your center C, this is the tangent line. The theorem states that a line tangent to a circle is perpendicular to the circle's radius. Okay. So this is our radius, right? So, sorry, it should be like this. So this radius and this tangent are perpendicular to each other. Okay. So this theorem is kind of important, and sometimes you will see questions that are based on this. And what kind of questions would you see, right? So let me give you an example. So one question could be, write the equation of the line that is tangent to the circle x square plus y square is equal to 13 at 2, 3. So how do we do this, right? So we're going to draw a circle and there's your center. Center is 0, 0, right? Because you can see the equation of the circle is x square plus y square is equal to 13. That means that center point was 0, 0, right? So now what they want, and then let's say this point over here is 2, 3. They want the equation of this tangent line, right? It's passing through 2, 3, and they want to know what the equation is. So this is where you'll use this theorem from before, right? You know that this point is 0, 0, and then you draw a line from here to there, and you know that this is 90 degrees, right? Now you can find the slope of the radius, right? You know 0, 0, 2, 3, you can find the slope of this line, which is what? y2 minus y1 by x2 minus x1. And your y2, y1 was what? 0, 0 and 2, 3. So 3 minus 0 by 2 minus 0, right? So your slope is 3 over 2. Now, remember, the tangent is perpendicular to the radius. So what is the slope of a line which is perpendicular to another line? So you know that, let me add a page here. Okay, so you know that perpendicular line slopes are, it's the negative of the reciprocal, right? So if the slope of the radius is 3 over 2, then the slope of the tangential line is going to be minus 2/3, right? So I'm just going to call that m1 because this was m. So now you have, now our focus is on finding the equation of the tangent line because that was the question. Now for equation of the tangent line, what do we need? We need slope and we need a point. But we know that 2, 3 is a point on that. So now you have point slope. So use the point slope formula, right? Point slope formula is what? Y minus y1 is equal to m into x minus x1, which is the point slope formula. So y minus 3 is negative 2/3 x minus 2. And so you just do a bit of algebra and you're going to get y is equal to minus 2/3 x plus 13 over 3. And this is a question that could be asked for circle. That's why this theorem was sort of important. Okay. The other kinds of questions that you will get in circle is pretty straightforward. You may be asked to, you may be given an equation like x squared plus y squared is equal to 49 and asked to graph it. So you just draw your coordinate plane, right? You know, because it's x squared plus y squared, you know the origin is the center. And if it's 49, let's write it in the form that we know, r square. So what of r square is 49? You know r is 7. So then you know that this distance should be 7 units. And so everything here should be 7 units, 7 units, 7 units, and then you draw a circle which is 7 units, right? Something like that. Just be more precise, but like this would be 7. Then the other thing that you could get is you could get the radius, right? Say the radius is, I don't know, 9 units. And the center is origin. Write the equation of a circle. So you know that it's x squared plus y squared is equal to r square. And so then you're going to write x square plus y square is 9 square. Don't forget that. Don't just write x square plus y square is equal to 9. It's 9 square. And so finally the equation is x square plus y square is 49 because the radius is 9 but the thing is r square. Okay. Then the other one you could get is it's passing through a point and the center is the origin. Okay, so that's one form of a question you could get. So basically this is as far as circles are concerned. We'll do the next conic section, which is parabola. Now we have learnt a lot of things about parabola. We did a lot of work with parabola last semester and maybe last year, even this year a little bit. So now going back again to the image in the beginning, parabola is, you take the same plane but you're kind of slicing the cone in kind of an angle like this on the top, right? When you do that, you get the shape of a parabola. Okay, so that's what's happening with this intersection of cone and plane. So it's all about how you take the plane and slice the cone. Okay, so in this angle you get the parabola. Now again, let's go back to the definition of the one with the locus, right? What is that definition for parabola? Okay, So with parabola, what we learned is, so far what do we know? We know that when we have a parabola, this is the vertex, and we know that this is your axis of symmetry. The axis of symmetry kind of divides the parabola, in two equal, right? It's the same distance. So if I were to take the distance from here to here, here to here, it's going to be the same. We know that part. Now we are introducing two more vocabulary terms for parabola. One is called the focus, and the other is called the directrix. Okay, the directrix is it's a line actually. It is, the property of the directrix is, one, it lies outside of the parabola. You can see the parabola is here and the directrix is here, and the directrix is always perpendicular to the axis. Okay, so that's the new vocabulary for parabola, directrix. The next one is focus. Now the focus lies on the axis of symmetry. Okay, that point, just like we had a vertex, this is focus. Focus lies on the point of symmetry. Now how are the focus and vertex connected with each other? The vertex lies halfway between the focus and the directrix. So the two new things that we learned about the parabola, which is the focus and the directrix, this vertex is halfway between these two. Okay, so that means this distance is equal to this distance. Now, what is the parabola? Parabola is so how do we form the parabola is, if you take points such that they are the same distance from the focus and same distance to the directrix, such set of points form the parabola. So if I were to take a point here, this distance and this distance should be equal. A collection of such points forms the parabola. That's why you can see this line. See, if you take this point, the distance from here to here is the same as the distance from here to here. If you take this point, the distance from here to the focus is the same as from here to the directrix. Okay, so such a collection of such points, if you join them all, the shape you get is a parabola. Now let's look at some equations. So if you look at this first one, the equation is x square is equal to 4py. Now where's the p coming from? That's the focus, right? It's 0 comma p. It's lying on the y-axis, so you can see this is 0.0 comma p. And remember, we said that this length is the same as this length. So that's why you can see that the equation of the directrix is y is equal to minus p. Okay. Same thing over here. This is another way when the parabola is this way. This is your focus, and then this is your directrix, right? So now it's nothing but x is equal to minus p. Now here the parabola is going this way, right? So you say x square is equal to 4py. The only thing over here is that it's a little confusing. The p is less than 0. Okay, obviously you can see it's on the lower part, right? So the p is less than 0. They just write 0 comma p, but p is less than 0, right? And you will also see that the equation is written as y is equal to minus p. And then you can ask me, but wait, this is like the positive side of the y-axis, right? Why is it minus p? But remember that p is less than 0. So what would this point have been? Maybe, I don't know, minus 3, let's say, right? So if you put minus 3 here, it's going to become y is minus 3. So y is equal to 3, and that's correct because it's on the positive side of x. So it's just confusing that they write it this way. But that's just how a directrix is always y is equal to minus something, minus p. Everywhere it's minus. Okay. So this is as far as parabola is concerned. What kind of questions will they ask you in parabola is some of them are pretty straightforward, where they will just give you like y is equal to whatever minus 3x squared. Does the parabola open up, down, left or right? Right? You know this from your before, right? You know that if a is negative, it opens downwards. If a is positive, it opens upwards. So those are easy. And then you may also get questions where you are asked to identify the focus and the directrix. Okay, so let's look at an example where we can do that. So it says, so let's say identify the focus and directrix given by, let's see, x is equal to negative 1/6 y squared. So you have to identify the focus and then you have to identify the directrix. Now, you write the original equation and then let's multiply both sides by -6. So we get y squared is equal to negative 6x. Okay. You know from the equations, you can see from these equations over here, right? You can use this as a reference, right? When you have y square is equal to 4px, we can say that 4p is equal to -6. Okay, so you know that p is equal to -6/4, which is -3/2. So remember our focus is p comma 0, right? So therefore it's -3/2 comma 0. And what is your directrix going to be? Your directrix is going to be x is equal to minus p. So that means x is minus of -3/2, which is 3/2. Okay. So that's how you identify the focus and the directrix. And sometimes they may ask you to draw the parabola and you just have to draw it. So in this case, the way I would do it is I'll draw my coordinate plane. I have x, I have y, and then remember my directrix is x is equal to 3/2. So somewhere here, right? I don't know if this is 0. I'm going to say 1, 2, 3, and 3/2 is like what, 1.5, right? So that is my x is equal to 3/2, which is the directrix, right? And then your focus is -3, -1.5 and 0. So then the same thing, let's go -1, -2. So negative 1.5 is going to be somewhere here. So it's all the points that are equidistant. So this is our focus. Okay, negative 3/2, 0. And so all of my points are going to be, this is my parabola. So basically what is it? All these points are equidistant from this and this. If I take a point from here, this is the same length as this. Same length. Right? All such points make up the parabola. So then this would be your parabola. You just draw this. I would actually show some of this, so then you're really very clear. You have labeled the directrix, you have labeled the focus, and you're showing that parabola is all the points that are equidistant from these two. And boom, then you're done. Okay. The one other kind of word problem that you might get with parabola is it is to do with a satellite dish, or sometimes like light reflector. So it's usually, it will be like this. It's like a parabola is drawn like this, and then you have like a light source. Okay, which is like called the focus. Okay, and what happens is that the light kind of bounces off from this parabola. Okay, and then it reflects like this. Okay, so every light will just bounce from here and go here, bounce from here and go here. So this is a parabolic reflector. So light is reflected in parallel rays. All these are parallel to each other. So this is sometimes it's a common problem that as a word problem you might get it. So it's also like in telescopes, it's the same thing. Parabolic mirrors, they are called. They're used in reflecting telescopes. Okay, so you might get a word problem to deal with this. So I'm going to stop here for circles and parabola, and then I'll make another one for the other two conic sections. So you can see this video and then answer some questions which I'll send you for circle and parabola. Okay.